All right, let's take a look at this one. Believe me when I tell you, believe me when I say this, because I understand if you're confused, I understand how you feel. I really struggled in college, like a lot, okay? I've said this before, I'm not a smart person, okay? But I'm a very hard worker. And in college, when you get to college, math classes, you kind of got to be smart. The stuff that I was doing to try to get my math degree, you had to be pretty smart for that. And I very rarely could do the problems. I could get some of them, but most of the time was like, I don't know. So I understand how you feel if you're struggling with this. I really do. It's frustrating, but then it feels really cool when you can do it. When you get one, you feel like, yes, I did this. Okay? So this problem, very similar to the previous one, right? Because on the left side we have a fraction, on the right side we have two pieces like so. All right? So what could we do? Could we decompose this fraction that's over here? A little bit more obvious that we could do that in this problem. Do we want to do that? You could. Okay? If you looked at this and you wrote everything in terms of sine and cosine, could you still do this problem? Yes, you could. It would probably take a little bit more work. All right? I'm not sure we want to do that. And the best advice I can give you is this when you look at these problems and you're supposed to verify. If I need to make this side look like that side, and I really mean this is the best advice I can give you. Don't look at all the terms and the sines and the cosines and the ones and the blah, blah, blah. Look at it as the pieces. What are the pieces in this problem? The pieces are a fraction, and then over here I have two things. So either those two things need to become one thing like this, or this one thing needs to become two things. That's the best advice I can give you about problems like this. So let's make the one thing two things and separate this, decompose this fraction. If I do that, the numerator goes over the denominator 2 times. Now over here I'm not going to do anything just yet, but let's simplify what we have, right? Our job is to make this side show that we have the same pieces as that side. What's tangent over tangent?
1 over 1.
Yeah, 1 over 1, or just 1, right? So anytime you have a fraction where it's the same thing on the top and the bottom, that's 1. If you want to cancel them and say it's 1 over 1, that's cool too, okay? What's 1 over tangent? 1 over tangent, I've seen that before. That's on my identity sheet. Oh yeah, that's cotangent. Ta-da! Right? Addition is commutative, so it doesn't matter what order they're written in. I have the cotangent, the plus, and the 1. Same thing on both sides. Check. There it is. Take the 2, separate. Or take the 1 and combine, but combining the 1 would be a little bit more complicated. Combining the 2 into 1.